Hello, good evening students. How are you all? So in the last class, we have started the chapter area related to circle, and today we will continue that one. So in the first these 30 minutes, we will revise the topics which we have discussed in the last class and some of the examples. So what we have discussed in the last class, that in this topic area related to circles, the area of circle, which is pi r square, and the circumference of the circle, which is 2 pi r, and area is pi r square, circumference is 2 pi r, and the relationship between radius and diameter is that radius is equal to half of the diameter. Second thing we have studied, that related to sector and segment. Like if this is a circle and these are the 2 points A and B, so area enclosed by the arc and the two radii, this area is known as sector. So AOB, you can see this is known as sector, and since AB arc subtends theta angle at the center, so if you have to find the area of the sector, there are two things we have to find. One is the area of the sector and one is the length of the arc. So area of sector, the formula was theta over 360 into pi r square, and theta should be in degrees. Similarly, the length of arc, which is theta over 360 into 2 pi r. These were the two things. So here the length of arc is this part. AB is the length of arc. So this is the length of arc, and that is the area of sector. Second thing was the area of segment. Now what is a segment? So if I join this line AB, which AB is the chord, so chord divides the circle into two parts. Those two parts are called segment, major and minor. So here the minor segment, which is formed by the minor arc. So like this shaded region, this is called the minor segment. Now in order to find the area for the minor segment, or simply the area of segment, we have to subtract the area of triangle from area of sector. So area of sector minus area of triangle OAB. This was the thing which we have studied in the last class. And now in order to find the area of the triangle, there are two cases. Sometimes they will give you right angle triangle, like in which the central angle is 90 degree, but if the right angle triangle is not given, the general form for the area of triangle is half into product of sides into sine theta, where theta is angle between sides. So like for example, like if we have a triangle like this, and this angle is 60 degree, this is 2 and this is 3, and we have to find the area of the triangle. So area of triangle is half into product of these two sides, which is 2 into 3, into sine of the angle between them, which is sine of 60 degree. So this will be the area of the triangle. So these were the things which we have studied in the last class, right? And we have done some questions also. So let's start with the question itself. So try this question, all of you, based on the area of sector and segment. So a circle of radius 21 centimeter angle subtended at center is 60 degree. So you have to find three things. Find length of arc. Second thing, area of sector. And third thing, area of minor segment. Find these three things, all of you. Angle subtended at the center is 60 degree. Radius of the circle is 21 centimeter. Three things you have to find: the length of the arc, or let me draw the diagram also. If you go through the diagram, it will be like this. This angle is 60 degree, and let's say this is A, O, and B. So length of arc means you have to find this AB arc, area of sector AOB, and area of minor segment, which is this shaded region. Shillong Center, do you know how to do this? In the last class we have done this one. No. Were you present in the last class? Then I have given you the formulas also. Do it, try to do it. All of you please solve this question. And if required, use the value of pi as 22 by 7. That's right, Senapati. The answer is correct. Good evening, Tamenglong Center. Okay, 8 students are present. Okay, try to solve this question. It's slightly close, Senapati, not exactly this one. Check your calculation once. Shillong Center, are you able to do this? Are you trying? Okay, I'm solving this now. Concentrate over here. See, it is given that the radius of the circle is 21. So this is 21, right? You have to find the length of the arc. Length of the arc means this length you have to find, this AB. So length of the arc formula, that is theta over 360 into 2 pi r. Theta is the central angle and r is the radius. So central angle is 60 degree, 60 over 360, and in place of pi you have to use 22 by 7. So 2 into 22 by 7 and radius is 21. Now just simplify all these. 60 will cancel out this one 6 times, 7 will cancel out this 3 times, this will cancel, this will be cancelled. So finally we will be left with 22 centimeter. So length of the arc AB is 22 centimeter, right? Getting it? Only we just have to substitute the values in the formula, that's it. Second part, area of sector. So this complete AOB we have to find. So area of sector is given by theta over 360 into pi r square. So theta is 60 divided by 360. In place of pi we can put 22 by 7 and r square. So radius is 21 into 21. So this will cancel out 6 times and this will cancel 2 3 times, this will cancel out 11 times, 7 3 21 and this 21 will cancel out. So 21 times 11, that is 231 centimeter square. So this is the area of the sector formed by the radius and the corresponding arc. Yes, Senapati, now it's right. And now the third point, which is called the area of minor segment. So area of minor segment in this case is this shaded region. Now how we can get this area of the minor segment? From the complete sector, if we eliminate the area for the triangle OAB, we can get the area of segment. So it will be area of sector minus area of triangle OAB. Now area of triangle, how you can find the area of a triangle? I have just told you the formula. Whenever the central angle is given and the two sides which contain the angle is also given, so area of triangle is given by half into product of sides, which is 21 into 21 into sine of angle between them. So sine of 60 degree, and sine of 60 degree you should know, that is 21 into 21 into root 3 by 2. So it will be 441 by 4 root 3. So this will be the remaining area of segment will be area of sector. which is 231 minus 441 root 3 by 4. So now you can simplify this one, substituting the value of root 3 as 1.73. So always remember the two things, value of root 3 and root 2. The value of root 2 is 1.414 and the root 3 is 1.732. These are the two values which you can put in this one to get the area for the segment. Shillong Center, is this clear? Is it clear now? And please, you have to do a lot of practice in these questions, because in these questions only two formulas are there, but lot of calculation part is there. So make sure that you are not doing anything wrong in the calculation. Senapati, is this clear? The third one, third part. Okay, so now try this. And one more thing, the important part is that if we have a hexagon, like this is a hexagon, a regular hexagon, the area for regular hexagon, a regular hexagon, it is made up of 6 equilateral triangles. A regular hexagon is made up of 6 equilateral triangles, because from the center, if you join all the vertices, you can see that the central angle is completely divided into 6 parts, 1, 2, 3, 4, 5 and 6. So central angle 360 degrees divided into 6 parts, which is going to be 60 degree each. And if this is 60 degree, these two sides are equal. Since it is a regular hexagon, so base angle will also be 60 degree. Therefore, since all the angles are of 60 degree, so it forms an equilateral triangle. And there are 6 equilateral triangles. So area would be 6 into area of one equilateral triangle. And area of one equilateral triangle is root 3 by 4 into side square. So area of one equilateral triangle multiplied by 6, that will give you the area of hexagon. Now try this question, all of you. Radius is 12 centimeter. Angle at center is 120 degree. Area of corresponding segment of the circle. And here use pi as 3.14 and root 3 as 1.73. So there is a circle and the radius of the circle is 12, and from 2 points the angle subtended at the center, that is going to be 120 degree. So you have to figure out the corresponding area of the segment. It will be like this. So this angle is given, so you have to find the area for this shaded region. All of you try this. And for pi you can use 3.14 and for root 3 you can use 1.73. This is the same question as we have done the previous one, only the calculation is different. Try this, all of you. The main thing over here is to find the area for the triangle. Try this, Shillong Center. A same type of question it is. Uh, that is not right, Senapati. The answer is not right. The main thing in this one is to find the area for the triangle. Area of sector is easy. To find the area of triangle, that is involves some logic. Okay, let me do this. So first thing over here, that if we draw the diagram, it will be like this. This central angle is 120 degree, and this is radius is 12, and this is 12. So in order to find the area for the triangle OAB, what we can do, we can draw a perpendicular from the center to the chord. The construction is, let's say OM is the perpendicular. So we have drawn the perpendicular from the center to the chord. Since OAB was an isosceles triangle, and drawing perpendicular from the vertex to the opposite side will bisect the side, because the two triangles which we can get over here, OMA and OMB, these are congruent triangle by RHS congruency, because one of the right angle 90 degrees is equal, hypotenuse which is radius is equal, and one of the side OM is common. So these two triangles are congruent. It means the AM and BM both are equal. So you can say that AM and BM both are equal, and the angle will also get bisected. This is 120 degree, so this will be divided into 60 degree. Now in triangle OAM, alone in triangle OAM, we can apply the sine of 60. So the sine of 60 degree, that is opposite over hypotenuse or perpendicular over hypotenuse. So perpendicular is AM, and hypotenuse is 12, and sin 60 is root 3 by 2 is equal to AM by 12. So AM is equal to 6 root 3. Now since AM is equal to 6 root 3 and BM is also 6 root 3, so therefore we can say AB is equal to 6 root 3 plus 6 root 3, which is equal to 12 root 3. This is the length of AB. And now similarly you can apply the cos of 60 degree. Cos of 60 degree is base over hypotenuse, so OM over OA. So cos of 60 degree is 1 by 2, OM we have to find, and OA is 12. So OM is equal to 6, or you can say the perpendicular distance of the triangle is 6. So the base, the complete base of the triangle is 12 root 3, height of the triangle OM is 6. So you can find the area of triangle, half into base into height. So this is finally going to be 36 root 3, that is the area for the triangle only. So now the area for the segment so area of sector, that is theta, which is 120 over 360 pi, which is 3.14 r square, 12 times 12. So that is all equal to 150.72. If you solve this one, you will get 150.72. This 120 will cancel out this one 3 times, this will be 4 times, and 48 into 3, that is 150.2, that is the area of the sector. Therefore, area for segment is complete sector minus triangle. So complete sector is 150.72 minus 36 root 3. That is the area for the segment. Is this clear to all of you? Sisipur, Senapati, Tamenglong, is this method clear to all of you? Now you can also put root 3 as 1.73 and then you can simplify your answers. Any doubt in this one? Senapati, Sisipur, Tamenglong, Shillong? And the answer, if you solve this one, the answer is going to be 88.44 centimeters square. This is the answer, not 76, neither 75. 88.44 is the answer for the area for the segment. Area of segment means the shaded region. This shaded region is the answer, 88.44. Okay, so we'll take a quick 5-minute break over here, and then we will start our correct session at 4 o'clock. And in this session, today's session, we will do the different variety of questions based on the area related to circle. So just revise all the formulas before starting the questions practice. It will help you. Okay. Okay, let us start with the questions itself then. So related to the area of the circle. So first question for you. There is a brooch made up of silver wire in form of circle having diameter of 35 millimeter. The wire is also used for making 5 diameters which divides the circle into 10 parts. So the diagram is like this. This is a circle. It is made up of a wire, cellular wire, and there are 5 diameters. 1, then 2, 3, 4, and one more, which is 5. So it divides the circle into 10 equal parts. So you have to find two things. Find total length of wire and area of each sector. Do these two parts. So basically the question goes like this. There is a circle of diameter 35 millimeter, and with the same wire which is used in making the circle, 5 diameters are drawn, which divides the complete circle into 10 equal parts. So you have to find what is the total length of the wire used and area of each sector. So there are 10 sectors, you have to find the area for one of them. A straightforward question it is, just substitute the values. And for pi you can use 22/7. Sisipur, are you getting this? Senapati, Sisipur, Shillong. Shillong Center, out of 4 students, how many of you are getting this? Raise your hand. Only 2. What about 2 in the front? How will you do this? You do know? No, that is not right, CC4. Check your calculation once again. No, it is also not right. Length of the wire means the outer circumference plus these divisions which we have made with the help of wire. That's right. That's correct, CC4. Correct answer. Now second part is simple one. Area of each sector you have to find. Five point five. Yes, Shillong, that is right. So the first part is very easy. What you have to do, the complete outer circumference, which is the circumference of the circle, and circumference is given by pi into diameter or 2 pi r, both are same. Pi is 22/7, diameter is 35, so it will be 7 5 times, and 22 into 5 is 110. Now 5 divisions has been made of length of the diameter, so that divisions is 35 into 5, which is 175. So total length is 285 millimeter, right? So this is the total length of the wire which is used. Now second one is area of each sector. So first of all, you have to figure out, to determine the area of each sector, you should know what is the central angle made. Now since this complete circle is equally divided into 10 parts, so complete central angle is 360 degree. So it is divided into 10 equal parts. So one part is of 360 degree divided by 10, which is 36 degree. So one part is of 36 degree. So now you know the central angle, which is 36 degree. Radius you also know, which is diameter we know 35, so radius is 35/2. So area of sector is theta over 360 into pi r square. R square is 35/2 into 35/2, because this is radius is 35/2. So this will be 10 times, this will cancel out 11 times, this will cancel out 5 times, this will cancel out 2 times. So it will be 35 into 11, which is 385 divided by 4 millimeter square. That is the area of each sector. 385 over 4. And you can convert this into decimal also. If you convert this into decimal, it will be 4 9 times 36. 2 is the remainder. 4 6 times 24, 96.25 or 96.25. All of you, is this clear to all of you? CC4, the second part is clear, area of each sector. Okay, so now let us try the next one. Question number 2. It says, a round table cover has 6 equal design. Radius of cover is 28 centimeter. So the diagram is like this. This is a round table and it has 6 equal designs like this. So the shaded region, this one, these are the designs. And these are the 6 equal designs. It means the shape in which you can see inside the circle, this is nothing but a hexagon. Like A, B, C, D, E, F. So A, B, C, D, E, F, this is a hexagon. So you have to figure out what is the cost of making these designs at the rate of rupees 0.35 per centimeter square. So first of all, basically what you have to do, you have to find the area for this shaded region, and after getting the area, to get the cost, just multiply the area with the cost. So first part is basically find the area, and only one thing is given, which is the radius of the circle, which is 28. And the hint is, since it is written 6 equal designs, and according to the diagram you can predict that A, B, C, D, E, F is a hexagon, a regular hexagon. And let me tell you one more thing, a hexagon is made up of 6 equilateral triangles. So if you can find the area of one equilateral triangle, if you multiply by 6, you will get the area for hexagon. Area of hexagon is equal to 6 times area of one equilateral triangle. Now do this. Find the area of shade region, multiply by 0.35, you will get directly your answer. And if required, use the value of root 3 as only 1.7. This is the value, 1.7 you have to use for root 3. No, that's not right. CC4, it's not right. Two 2.8. It's very small, 2.8. No, CC4, that's not right. First of all, find the area for the shaded region. For that one, find the area of the complete circle, subtract the area of hexagon from that. First of all, area of circle, radius is 28. So area of circle is pi r square. So pi is 22/7 and radius 28 into 28. So just calculate this one. Then since this is a hexagon and it is made up of 6 equilateral triangle, so let's say this is ODC, this is one equilateral triangle. So hexagon area is equal to 6 times area of triangle ODC, and area of equilateral triangle is given by root 3/4 a square. A means the side square. Side is again the 28. So calculate these two things. Therefore, shaded region area would be circle minus hexagon. If you calculate, this will be equal to 2464 centimeter square. This will be 1176 root 3, and you can put 1176 root 3 as 1.73. So that would be equal to 2036.89. Now just subtract both of them. So area of shaded region is this one, 427.10 centimeter square. And now just multiply this, since the cost of making 1 centimeter square is 0.35, so total cost is into 0.35. That is 149.48. See, the calculation is very important in these questions. Is this clear to all of you? So questions are directly straightforward. You just have to observe like how you can figure out the shaded region area. Now, the third one. Try this question. The diagram is like this. There is a circle. Here O is the center of the circle, and triangle PQR you can see. PQ is going to be 24 centimeter, PR is 7 centimeter. Find area of shaded region and use pi as 22/7. Here one concept of circle will be used, which you have studied in the 9th class. I hope you remember that in the 9th class you have studied one theorem, that angle subtended in a semicircle is always 90 degree. So here QR is the diameter and angle QPR is the angle subtended at the center. So this is going to be 90 degree. This angle QPR, this is 90 degree because it is the angle in the semicircle. So Sisipur, how's the weather there? Is it rainy? Senapati, what's your answer? Are you getting it? .14 you're getting. No. That is not right. Okay. Now just concentrate. I'm solving this. First of all, you can see that you have to find the area for the semicircle. And area for the semicircle you can find if you know the radius. So first of all, focus on how you can get the radius. RQ is the diameter over here, and triangle PQR is right angle triangle. Since angle P is 90 degree because angle in a semicircle. Now, by the Pythagoras theorem, you can say since P is 90 degree, so RQ is hypotenuse. So RQ square is equal to RP square plus QP square. So RP is 7, so 7 square is 49, and this is 24. 24 square is 576. So that is going to be 525. Oh, sorry, 625 it will be. So it is 625. So RQ square is 625. So RQ is equal to 25. So the diameter of this circle is 25. If diameter is 25, you can say radius is 25 by 2 centimeter. This is the radius. Therefore, area of semicircle is pi r square divided by 2. So 1 by 2, pi is 22 by 7, and radius is 25 by 2. So 25 by 2 into 25 by 2, we can do like this. This will be 11 times. So it will be 625 into 11 divided by 28. That is the area for semicircle. Now you have to figure out the area for that triangle also. So area of triangle is, this is a right angle triangle because it is forming 90 degree, you can see. So directly you can do half into base into height. So half into RP into PQ. So that is going to be half into RP. RP is 7 and this PQ is 24. So 12 7 times 84. This is 84. So area of shaded thing is 625 into 11 by 28 minus 84. I'm not solving the exact part. This is the expression which will be formed. Yeah, 4523. So now just you can get the correct answer. So this is the way in which it should be solved. So three things is checked over here. First, you should know the theorem from the 9th class that angle in a semicircle is 90 degree. Second thing, you should know how to solve Pythagoras. Third thing, you should know how to do the calculation for semicircle minus triangle area. Yes, Kohima, that is right. So Kohima has given answer 4523 divided by 28, and this is the correct answer. I hope all of you got it. Senapati, now you got it? Any doubt in this question? Should I explain it once again or shall we move to the next one? Shillong, clear hai? Okay then. So let's move on to the next one. Now, if you remember in the last class एक question करा था हमने जिसमें इस type का question था ये like a rectangular field was there and from the end point of the rectangular field a horse is tied or goat is tied and without entering into the field that how much area it can graze outside the field. How many of you remember that question? Okay, यहाँ पे सबको याद है. And Sisipur, Senapati, do you remember that question? There was a rectangular field and from the end point one animal was tied and we have to find the area it can graze outside the field. Okay, so if you know that concept, तो उसी के basis पर एक और question है. It's a very good question and so I will explain you how to do this. So note down the question. Question starts with the diagram itself. Like all of you know what is a hexagon. So this is the hexagon. A regular hexagon of side as A. The side length is A. And from this end point, again it is a fenced hexagon field. Fenced hexagonal field. And from the one of the vertices, a horse is tied or a goat is tied with a rope having the length 3a. Side of the hexagon is a and the length of the rope is 3 times of the side, which is 3a. So again you have to figure out how much area it can graze outside the field without entering into the field. Again it is fenced field. So without entering means neither the goat can go inside the field nor the rope can go inside the field. So first of all think like the logic. I'm not saying you to solve this one. First of all think how you can proceed in this one. If you get the logic like we can proceed in this way, then let me know. And Shillong Center just think what should be the diagram like you remember that when we were doing this type of question when it was like this, so what we have done we have made a diagram like this and then this was rotated about this point and this was rotated about this point. It was something like this, right? When we were doing the rectangular problem. So here it is like hexagon. So think in the same way, the rope will get tilted by each edges or each vertices. And you should also know like what is the angle of rotation. Like it was the rectangle, so angle was 90 degree itself, but here it is hexagon. So you should know it is a regular hexagon. So you should know what is the central angle, what is the what is the measure of each internal angle of the hexagon also. These are the concepts which will be required in this question. And give your answer in terms of pi and a itself. No need to substitute the value for pi. Just we have to calculate the answer in terms of pi and a, which is the side length. Shillong Center, are you getting it, like how to proceed in this one? कैसा डायग्राम कैसा होगा इसका, समझ में आ रहा है कुछ? And Senapati, Sisipur, Kohima. Tamenglong Center. Are you getting like how the diagram will look like? Shillong, how many of you got the logic, like कैसा डायग्राम होगा और किस तरह से प्रोसीड करेंगे? Okay, that's great. Okay, shall we do this question? Start करें से? Shillong. Okay, देखो. First of all, you have to figure out what is the central, what is the angle measure of the hexagon. You remember that one formula was there, n minus 2 into 180. This was the formula to figure out the sum of internal angles of a polygon, where n is the number of side. So if you divide this by n, that will give you n minus 2 into 180 divided by n, that will give you the measure of each internal angle. So here we are talking about the hexagon. Hexagon has 6 sides. So if you put n as 6, so it will be 120. So measure of each internal angle is 120. Like this angle is 120, this angle is 120, like this. Now, since this is the rope of length 3a, so first of all we have to see how much it can extend. It can be extended. So it can be extended like this. From this point up to here it can be extended, and up to here it can be extended, and the horse can go like this in this direction. The complete sector of a circle it can make. It is go in this direction like this. Now, since the length of the side is a, so the remaining part of the rope is, this part left is 2a. Now this will get bent against this vertex. So it will get bent again about this vertex. So it will be like this. It can cover this much of area, right? Now since this length is also a, so remaining length of the rope is a over here. And now this remaining portion will again get bent about the vertex. Since this is also a and this side is also a, so it will be bent exactly at the top vertex like this. Similarly, the left side also will work like this. It will be like this, bend like this, and then again bend like this. So let us name these sections as A, B, this is C, this is D, and this is E. So these 5 regions you can see, this is the area which the horse can graze. And all these 5 are the sectors. So radius of each sector you also know, only you have to figure out what is the angle. Now you know that this internal angle is 120 degree, it means this outside angle, this has to be 240 degree for the sector C, because total angle around a point is 360 degree. Similarly, for this section B, this is 120 degree, so this central angle, this one is of 60 degree, because internal angle is 120 degree and this is a straight line, and the sum of the angle of the straight line is 180 degree. And similarly for this one, sector A, this is also 60 degree, and same goes for D and E also. Any doubt till now? Shillong Center, ये clear है यहाँ तक diagram? Okay, CC-Pur, Senapati, Kohima, is this clear, the diagram? Okay, so now, and now you can see that the area for A is equal to the area of E, and area of B is equal to the area of D. So A and E have the same area and B and D have the same area. So you can just find the area of A and B and make it double. So now let us find the area, total area. So total area is C, area of section C, plus twice of A plus twice of B, because twice of A, why I am doing twice of A? Because it will include A and D both, and twice of B means it will include B and D both. Now for C, angle is 240 degree. So theta over 360 into pi r. The radius for this one is complete length of the rope, which is 3a r square, plus 2 times of a. For a, the central angle is 60 degree, and the you can say the length of the rope is a, radius is a. So 2 into, or you can take 2 as common from a and b both. So theta over 360 pi r square. This is for A, and for B, theta over 360 pi r square. The radius for B is 2a. I have taken 2 common from both A and B. Now we can just simplify. This is 240 over 360. That is, we can divide it by 120. So it will be 2 by 3 pi 9a square plus 2 times of, that is 1 by 6 pi a square plus 1 by 6 pi 4a square. And this will cancel out, this 3 will get cancel out this 3 times. So 6 pi a square plus 2 times of, that is pi a square plus 4 pi a square, that is 5 pi a square, divide by 6, and this will cancel out 3 times. So if you take the LCM over here, that will become 18 plus 5, 23 by 3 pi a square. That is going to be the complete area for the grazing field. Is this clear? Shillong? समझ में आ रही कैलकुलेशन? अच्छा क्वेश्चन, इट्स अ वेरी गुड क्वेश्चन. The concept wise the question is very good. हाँ सीसीपुर, क्या बात है, अच्छा है क्वेश्चन. Sisipur, what's the meaning of this? I don't understand. Like, okay, so now let us do the next question. So try this one. This one is a easy one, you can do it. ABCD is square of side 14 centimeter and APD and BPC are semicircles. So find the area of shaded region. and you can use the pi as 22 by 7. Do it. This is the square and two semicircles are there. So you have to figure out the area for the shade region, and the pi is 22 by 7. That's right, CC4. Correct answer. That's right, Shillong. It was a easy one. Only just the area of a square minus the area of the circle, because two semicircle will make a complete circle. Perfect, perfect. So just shaded will be area of a square is 14 into 14 minus area of circle, which is pi, and radius will be diameter is 14, so radius will be 7. So pi r square. So 196 minus 154, which is 42 centimeters square. Okay. Okay, so let's take a break over here, and then after the break we will do the next questions. Okay. Okay, welcome back students. Shillong center, now focus. Okay, so let us start with the question. Next one. So try this. Triangle ABC is equilateral triangle and the circle has a radius of 6. So you have to find the area for the shaded region, this one. Find the complete area where A is also the center of the circle. Triangle ABC is equilateral and the circle is having a radius of 6. Use pi as 22/7. And give your answer in terms of fraction or root itself. Yes, that's correct, Shillong center. But you have to find the complete. That's right. Correct, Koima. Perfect answer. See, here first you have to find the area for the triangle, area for the circle, and then you have to subtract the common region. The common region over here is this one. This common region, this is smaller sector, you have to subtract this one also. So area of triangle, so triangle area is root 3 by 4 a square, and a is the side, which is 12 square, which is 144 over 4, which is 36 root 3, that is the area for triangle, first part. Second part is the area for the circle, pi r square, radius is 6. So 22 into 36 divided by 7, that is the area for circle. And third part is the common region. So common region is the smaller sector, you can see, this one. This in pink color, this is the common region which we have to subtract, because when you will add the circle and the triangle, this will be counted twice. So we have to subtract that one. And since this is a sector and this sector is a part of the equilateral triangle, so central angle is of 60 degree. So theta over 360 into pi r square is 36. So it will be 1 by 6, or it will be 6 pi, right? So, or you can also do it like this, 6 pi is nothing but 6 into 22 by 7, or 132 by 7. So area is area of triangle plus area of circle minus area for the common region. Just simplify this one, that is the final answer. I hope this is clear. Now try the next one. ABC is quadrant of circle of radius 14 centimeter, and a semicircle is drawn by taking AC as diameter. So find the area of our shaded region. And use pi as 22 by 7. This is the ABC is a triangle, a part of a quadrant of a circle. A quadrant of a circle means 1/4 of a circle, that is ABC. And by taking AC as the diameter, again a semicircle has been drawn. So you have to figure out the area between these two regions. Yes, the Tamenglong Center. That is right answer. Correct. Perfect. Shillong, what is your answer? Integer you will get as an answer. No, Sisipur, that is not right. It's a very different answer you are getting, not even close. No. See, first of all, you have to see that ABC is a quadrant of a circle. So this region, this ABC, a quadrant of a circle, means this is the quadrant. So how you can figure out the area for the shaded region? Just find the area for the triangle ABC, area for the semicircle. So shaded region area is area of triangle ABC, a right angle triangle it is because this is 90 degree, plus area of that semicircle. On the top we are having ACS diameter, adding these two minus area of this quadrant, adding the area of triangle plus semicircle minus area of quadrant, that will give you the area for the shaded region. Now this radius is 14, this is 14 and this is 14. So by the Pythagoras, if you do the AC, that will be 14 root 2. By the Pythagoras theorem, if you find AC, that will be 14 root 2. So area of triangle ABC, ABC is a right angle triangle, so area is half times base times height. So half into 14 into 14. No, Shillong, that is not the correct answer. Plus area of semicircle. Now for that semicircle, the radius is, for this semicircle, radius is 14 root 2 divided by 2, which is 7 root 2 is the radius. So area is pi r square by 2. So pi r square 7 root 2 into 7 root 2 divided by 2. That is the area for semicircle. Yes, Kohima, that is correct. Minus area for the quadrant. Quadrant means 1/4 of a circle. So 1/4 of a circle, which, and the radius is 14 for that one. So pi r square 14 into 14 divided by 4. This is the expression which we will make. So this will be 98 and this will be 7 will get cancelled, this one, this 2 root 2 will cancel out this one. So 22 into 7, that is 154, minus this 2 times, 11, 2 7 times, and 11 into 14, that is also 154. So 98 plus 154 minus 154, that is going to be 98. So this is the area. Shillong, समझ में आ रहा है? In the front row, look straight. Shillong में. समझ में आ रहा है? Sisipur, is this clear? Okay. Now try the next one. So this is the square. This is 8, 8, 8 and 8. So basically these are the two quadrants. Like if you talk about ADC is a quadrant. Quadrant means 1/4 of a circle, and BAC is a quadrant. These two are quadrant and of the same circle. So radius is 8, and you have to find the area for this shaded region between these. These are the two quadrants, or you can say the arc AC has been made by taking D as the center and arc AC by B as the center. By taking D and B as the center, we have drawn two arcs. Okay. Okay, okay, Shillong, I got it. I got your point. Now try this. By taking D as the center, that arc, and by taking B as the center, those two arcs has been made. So you have to figure out the area between these two arcs. And this outside is 8, 8, 8, 8. And find your answer in terms of fraction. And take pi as 22/7 also. Zero. CC4, how answer can be 0? There is something. How the area can be 0? Kohima, your answer is right. Correct. Okay, okay, okay. Perfect answer. No, CC4, that is not the right answer. Senapati, what's your answer? You're not giving any responses. Very good, Tamenglong Center. That is right. No, CC4, that is not the right answer. And those who have done the 7th one, try this 8th one. This is the square of side 10, and this center point is the center, and these are the 4 semicircles by making 10 as the diameter. So you have to figure out the area for the shaded region. No, Shillong, that is not the right answer. See, in this question 7, in order to get the area for the shade region inside one, just join this AC first of all. Right. Now, this region, if 8 and 8 is there, so you can say AC, by Pythagoras you can find AC as 8 root 2, right? So now, what you can do, you can find the area for this quadrant ADC. The quadrant ADC you can see, it is 1/4 of a circle having the radius of 8. So which is pi r square divided by 4, which since the radius is 8. So 22 into 16 by 7, that is the area for quadrant, and area for triangle ADC you can do. If you subtract the triangle ADC from the quadrant, you will get the only the half part shaded region. So area of triangle ADC, that is again a right angle triangle. So half times base times height, which is 32. Now shaded is quadrant minus triangle. Now if you double that one, that will be the complete shaded region, because this region is also the same method. By same method we will get this one. So just double this one. So this thing multiplied by 2, that will give you the complete answer. So just solve this one, you will get this one as 256 by 7. That is the answer. This one, 10th one is a very, 8th one is a very good question. and find your answer in terms of pi. In the 8th one, find answer in terms of pi. No need to substitute the value for pi. Are you getting this? How to attempt this question? सीसीपुर, शिलोंग, समझ में आ रहा है कैसे होगा ये क्वेश्चन? So I can expect answer from you people. Yeah, I am waiting. CC4, don't worry. That's correct, Tamenglong. No, Sisipur, that is not the right answer. $252. No, that is not the right answer. Okay, I'm solving this now. Focus how we can expect. So, in order to get the area for the shaded region, what you can do, you can find the area for the unshaded region and then you can subtract it from the total area. So, let us say the area of unshaded region, let us denote this by A, this one by B, this one by C, and this one by D. So, if you can find the area for A, B, C, D and subtract it from the total, you will get the area for the shaded one. Now, how you can get the area for A plus C? So, can I say area for unshaded region A and C we can get from the total square if you subtract these two regions, this circle and this circle. If from the total square, if we subtract these two semicircles, we are left with the area for A plus C. So, you can say A plus C is equal to area of square. Area of square is 100 meter square, because since it is 10, so 10 into 10 minus area for this complete circle, because this is one semicircle and this is another semicircle, so it will make a one circle and having the radius of 5. So, pi r square. So, it is going to be 100 minus 25 pi. That is the area for A plus C. In the same way, in order to get the area for B plus D, again we have to do the same thing. We have to subtract the upper semicircle and lower semicircle, and answer is going to be the same, 100 minus 25 pi. Therefore, A plus B plus C plus D, that is 200 minus 50 pi, adding. Sorry. So, A, B, C, D, that is 200 minus 50 pi. Now, in order to get the shaded region area from the total area of a square, just subtract the area for A, B, C, D. So, therefore, shaded region is equal to total area minus A, B, C, D. So, total area is again 100 minus 200 minus 50 pi. So, 100 minus 200 is minus 100 and plus 50 pi. So, 50 pi minus 100. That is the correct answer. And if you are going to substitute it with 3.14, the pi, that will be 157 minus 100, which is going to be 57. Pi minus 100. Yes, Senapati, that is right. Shillong, are you getting this now? And the one of the useful tip for these question is that always substitute the value of pi in the end. don't substitute the value of pi in between, because it will help you to simplify the problem. So substitute the value always in the end. Now try this one. OABC is a square, and ODBE is a quadrant. OA is equal to 20. Find the area for the shaded region. Try this. And here use pi as 3.14 in order to get the exact answer. CC4, that's right. Correct answer. Senapati, what about you? Finally, in this attempt, you got the correct answer in the first attempt. Yes, yes, Shillong, I am waiting for you. Only you are left in the class. So, CC4, how many students are there in your class right now? Okay. And what's the weather there? Is it raining still? Yes, Shillong, that is right. Perfect. Correct है इस बार तो. And Senapati, what about you? क्या आंसर आ रहा है? Just find the OB that will work as the radius of this quadrant, and since OABC is a square of side 20, OB is 20 root 2. So area of quadrant, which is pi by 4 r square minus area of a square, which is 400. That is the answer. Area of quadrant minus area of square. So that will be 400 into 2. So 200 into 3.14 minus 400. That will be 628 minus 400. That will be 228. That is the answer. So I hope you got it, all of you. Okay, so this was all about the area related to circles. And if you have any doubt in any of the questions related to this, go through your book. If you have any doubt, you can post your queries on the group. And otherwise, in the next class, we are going to start a new chapter. And you can give your suggestions also in the group that which chapter you want to start with. Then we will decide. Okay then. Thank you. Bye. See you in the next class.